Dear friends, in continuation of wave optics, the second lecture is Michelson interferometer. In Michelson interferometer, first discuss principle and working. When a beam of light from monochromatic source is incident on a half silvered glass plate, it is divided into two parts. One part is a reflected wave and other part is a refracted wave. After reflection from mirrors M1 and M2, when they superimpose each other, they produce interference fringes. Interference means superposition of the two and more waves. P and C are two optically parallel glass plates of same thickness and same material at an angle 45 degree. The surface of plate P towards C is half silvered. There is no polish on plate C. This plate is called compensatory plate. Action of compensatory plate. In absence of plate C, the reflected wave passes through the plate P twice, whereas the refracted wave does not pass even once through the plate P. Therefore, the optical path of reflected and refracted wave not equal when mirror M1 and M2 are at equal distance from plate P. In order to equalize the optical path of these waves, a plate C is placed parallel to the plate P. This plate is called compensatory plate. This plate is called compensatory plate. Next, formation of fringes. Two types of fringes are formed in Michelson interferometer. First, circular fringes. The condition of circular fringes depending on the position of mirrors M1 and M2. Mirror M1 is parallel to M2 dash, then the air film is between M1 and M2 dash. If the thickness of film is small d, then the light reflected from M1 and M2 dash will be look as coming from the virtual source S1 and S2. Then we get the path difference between the two waves 2d cos theta plus lambda by 2 equal to n lambda in condition of maxima, and 2d cos theta plus lambda by 2 2n plus 1 lambda by 2 condition of minima. These fringes are called Hedinger fringes. Next fringe is localized fringes. When the mirror M1 and M2 are not perpendicular to each other, then M1 and M2 dash is wave shape film is formed. These fringes are known as localized fringes. When M1 intersect M2 dash is centered, the fringe will be straight. Okay. Determination of difference in wavelength between two nearly equal wavelengths. Two nearly equal wavelength means difference between two wavelengths. Suppose D1 and D2 lines. This condition is seen in sodium light. In sodium light, two wavelengths are appear 5890 angstrom and 5896 angstrom. Let the light emitted by source two wavelength lambda and lambda 2 which are nearly equal. The fringe pattern formed by two wavelength lambda 1 and lambda 2 is separately, but as the difference between the two wavelength is very small, then the two patterns overlap. Let's lambda 1 formed fringe nth fringe and lambda 2 formed n plus nth fringe. Then solve this condition and we get the formula of delta lambda. Delta lambda is called the difference between two wavelength, or lambda is called mean wavelength. D is the difference between two plates, and then we get a formula delta lambda is equal to lambda square upon 2d, or d is called distance between two mirrors, M1 or M2 dash. M1 or M2 dash is both are parallel, but M1 or M2 both are perpendicular to each other. Okay.